This video covers the fundamental concepts of electric current and voltage. We will review the relationship that current is the rate of flow of charge, where charge equals current times time. Additionally, voltage is the energy transferred per unit charge passed, and a volt is a joule per coulomb. Electrical conductors allow electric current to flow easily. All metals are conductors. Electrical insulators have a very high resistance to the flow of electric current. Electric charge can be either positive or negative. Electrons have a negative charge, protons have a positive charge of the same size, and neutrons have no charge. An uncharged atom has an equal number of electrons and protons. Electric current is the rate of flow of electric charge. 1 ampere flows when 1 coulomb passes in 1 second. In metallic conductors, electrons carry a negative charge from the negative to the positive side of a power supply. The charge-current equation is electric charge equals current multiplied by time, or Q equals I times T. This can be rearranged to find current or time. Let's calculate the charge passing through a device when a current of 500 milliamperes flows for 3 minutes. Using Q equals I times T, we convert the current to 0.5 A and time to 180 seconds. The resulting charge is 90 coulombs. Next, calculate the current flowing when a charge of 240 coulombs flows through a device in 80 seconds. The formula for current is I equals Q divided by T. Current equals 240 C divided by 80s, which is 3 amperes. Here is a table for practice calculations involving charge, current, and time. The answers for the missing values are 30 seconds, 65 coulombs, 3 amperes, and 60 seconds. Voltage is defined as the energy transferred per unit charge passed. It is calculated by dividing energy by charge. 1 volt is the same as 1 joule per coulomb. Calculate the voltage of a battery if it supplies 300 joules of energy to 50 coulombs of charge. The voltage equals energy divided by charge, which is 300 J divided by 50 C. The battery voltage is 6 volts. Let's work through some practice calculations using the voltage equation. V equals E divided by Q. Here are the answers to the missing values: 40 C, 20 volts, 120 J, and 300 C. Now, let's fill in the gaps for these sentences. The word selection is provided below. Electric current is the rate of flow of electric charge. Electric charge is measured in coulombs. A battery provides electrical energy. The amount of energy provided per coulomb is equal to the voltage. The main supply gives 230 joules to every coulomb of charge. An electric current only flows if there is a complete, unbroken electric circuit that contains a power supply. Circuit diagrams use standard symbols to show how components are connected. Review the common circuit symbols for a cell, battery, wire junction, and switch. Remember their purpose in a circuit. Other symbols include the indicator, light bulb, ammeter, and voltmeter. The ammeter measures current, and the voltmeter measures voltage. Additional symbols are the fixed resistor, variable resistor, thermistor, and light-dependent resistor, or LDR. Finally, we have the diode, LED, fuse, and heater. A diode only allows current to flow in one direction. Electric current flows from the positive terminal of a power supply around a circuit to the negative terminal. The longer, thinner line on a cell symbol indicates the positive terminal. Now identify the following circuit symbols. The symbols correspond to the ammeter, indicator, diode, heater, cell, thermistor, LDR, and fixed resistor. Draw the circuit diagram for the torch shown in the image. The components are a battery, a switch, and an indicator, or light bulb. Components connected in series share the same electric current. The cell and the 2 lamps in this diagram are in series. In a series circuit, all components can be controlled with 1 switch. Components share the voltage of the power supply, meaning adding more bulbs makes each one dimmer. Now let's examine parallel circuits. The voltage across each component connected in parallel is the same. In a parallel circuit, components can be individually controlled with separate switches. If one light bulb fails, the others will continue to work. Regarding currents in parallel circuits, the total current through the entire circuit is the sum of the currents through the separate components. I total equals I1 plus I2. What are the advantages of connecting 2 lamps in parallel rather than in series to a power supply? Parallel connection results in brighter lamps, individual control via switches, and ensures that one lamp continues working even if the other does not. We are asked to calculate the currents measured by ammeters A1, A2, and A3 in the circuit diagram shown. A1 measures 2A, A2 measures 4A, and A3 measures the total current, which is 6A. This is because the total current is the sum of the currents in the parallel branches. Finally, choose the appropriate words to fill in the gaps for this summary of series and parallel circuits. The word choices are provided below. When components are connected together in series, they will all have the same current flowing through each of them. When connected in parallel, they will each have the same voltage. Lamps are usually connected in parallel as this allows them to be controlled individually by switches, and if one lamp blows, the others continue to operate.